Hello children, today I have taken this example of Hibiscus rosa sinensis for the study of family Malvaceae. So using this live specimen, today we will study how to describe the floral parts of this flower. Here we can see that this is a solitary flower, okay, and at the base this is the pedicel of the flower, and at the base of the pedicel you can see that a leaf is attached. So this leaf will be called as a bract because it is attached at the base of the pedicel. Now let us see the other parts of the flower one by one. So we have already seen that this is the pedicel of the flower, okay, this is the pedicel, and here it is the thalamus part which is seen here, the base. This is the thalamus part to which the sepals, petals, and rhecium and gynoecium is attached. So what all is visible here? We see that the sepals are present. We can see the green colored sepals here, okay, and we will take it out one by one and count how many are there. Here there is also this leafy structure outside the sepals. This is called as the epicalyx. So this is the calyx. The sepals are collectively called calyx, and above it you have the epicalyx, okay, and the petals are red in color, and we can also see the anther. These yellow colored numerous structures are the anther, and at the tip we can see that there are 5 stigma. So this red blob that you're seeing on top here, that is the stigma, and you can see that they are 5 in number. Now I'll take out each part and we will study how many are there separately. So I'm taking out the epicalyx now and I'm placing them on the paper. So you can see I have taken out the epicalyx and I have put them in a line so we can count them easily. They are 6 in number. Next, let me take out the sepals which are there, that is collectively called as calyx. And here we can see that the sepals are all attached to each other, and they are united here. You can see it. So they are gamosepalous and green in color. So I'll take out the sepals and we will see how many sepals are there. So I'm using a needle here and I'm taking out the sepal. Lightly take it out like that. You can use a needle so that it's easier to use, and you will get a neat section there. Okay, so I have taken out the sepals. You can see it has come out beautifully, and now I'll place this also on the paper below the epicalyx. So now if I flatten it, I can count that there are 5 sepals and all the sepals are joined together, so it is gamosepalous. Next, let us see about the petals. So petals, you can see here, it's one side out, one side in. You can see it here, okay. So this side, if I take this petal into consideration, then this petal has one side which is outside and the other side is inside the other petal. So this is showing twisted aestivation, whereas the sepals were showing the valvate aestivation. Here we can also see the thalamus part now. Okay, this is the thalamus part, and we cannot see the gynoecium or the ovary here. That means ovary must be inside the petals, and it should be that the petals and sepals are coming from below the ovary because this is a thalamus, and therefore this type of ovary is called as superior ovary, and the arrangement is also called as hypogynous. Now I'll take out each of the petals carefully and place it on the paper. So now I have arranged the 5 petals on the paper, you can see, and I have taken the staminal tube and using a needle I have split it open to see the ovary. You can see the ovary now, the style and the stigma. So staminal tube and the gynoecium I have arranged side by side, and it's okay. So now I have arranged everything properly on a paper. This is how you'll do in your practical exam also. So this is family Malvaceae, and the example is Hibiscus rosa sinensis. Epicalyx we studied. There were 6 of them, so you can see 6 of them are there. These are the epicalyx. Next, inner to that is the whorl of calyx, which includes 5 sepals. They are green in color and they are united, so gamosepalous, and the aestivation is valvate aestivation. Then there are, coming to corolla, there are 5 corollas, and so 5 petals, red in color, and they might look as gamopetalous, but then on the top they are free, so let's write it as polypetalous and fused at the base, because then only the staminal tube will be attached to them. So they are fused at the base but free at the ends. Okay, and aestivation is twisted aestivation. Then coming to the andrecium part, andrecium is in the form of a staminal tube, and there are many stamens, so we can write it as numerous stamens also, and they are all forming one bunch. We saw it in the flower, so it's monoadelphous, and at the base here it was attached to the petals, so the condition is called as epipetalous. And you can also label the parts as a staminal tube, this is a filament, and at the tip you have the anther. Coming to the gynoecium, gynoecium is pentacarpellary, which we can know by the number of stigmas there on top. We will also take a section and see whether it's correct. Then all the 5 carpels are fused together to form one structure, so it's syncarpus. And the position of the ovary we saw with respect to the other plants, so it was superior ovary and also called as a hypogynous. So now let us take the section of the ovary, the transverse section of the ovary, and see how it is inside. Now I've cut the ovary and I've taken as many parts as I could. So let me take out one section which we can see clearly. This looks like a good section. Let me take this and we will study how many parts or locules are there and how many carpels are there. So I've magnified it, and we can see now the ovary has 5 carpels. See, this is one carpel. You can see one septa here, another septa is here, the third one is here. After each 2 ovules you can find a thin septa. I don't have a dissecting microscope now, otherwise it would have been clearer in under the microscope. Anyway, we can make out that there are 5 septas here, which is dividing the ovary into 5 compartments. Okay, and that means that this is actually 5 carpels which have fused together to form a syncarpous ovary. And each of the locule is the space between the septa in which the ovules are present. So each locule has many ovules in it. If you can do it yourself, you will find out that there are many ovules in each of these locules. So if you consider the 5 locules, it is pentalocular, and there are many ovules in each of the locules. So that is about family Malvaceae, and the example that we studied today was Hibiscus rosa sinensis. And we can write the floral formula now, and we'll draw the floral diagram also. Okay, so the floral formula can be written as bracteate, so BR for bracteate. Then the flower can be divided into equal halves in any of the planes, so actinomorphic. Then the flower had both andrecium and gynoecium, so it is bisexual, and it was a complete flower. The outermost whorl was that of epicalyx, so you can write epicalyx, and they were I think 6 in number and free, so no bracket there. Then we come to the sepals or the calyx, which is represented by the letter K, and there were 5 of them which were united, so gamosepalous. And then next was the corolla. There were 5 red in color and mark it as free, polypetalous, but fused at the base. Then andrecium, there were many in number, so you can write it as infinity and all in one bundle, so monoadelphous, shown as bracket. and also with the help of a staminal tube they were attached to corolla, so that is epipetalous. Okay, so infinity is a number bracket because one bunch monoadelphous. Then coming to gynoecium, the gynoecium had 5 carpels, so pentacarpellary. It was syncarpous, so put it in bracket, and the ovary was superior, so draw a line in the base. This is how you write the floral formula of the family Malvaceae, that is example hibiscus. So this is how we draw the floral diagram. I have already drawn it and kept, so that we don't waste much time in drawing it. So this is a floral diagram as it is given in the floral formula. We have the epicalyx, which was 6 in number, so 1, 2, 3, 4, 5 and 6. So you do it like this, just like we draw sepals, we will draw epicalyx but smaller in size. Okay, 6. Then inner to that were the sepals, so 5 in number, 1, 2, 3, 4, 5, and it was gamosepalous, so you will draw it joined to each other like this. Okay, so this is how you draw the sepal. It will be pointed at this end and it will be like this in the inner side. Then coming to inner to the sepals, it was the petals, so they were 5 in number, and it was twisted aestivation, so 1 in 1 out of the petal, 1 inside 1 outside, that is twisted aestivation. And it was polypetalous but then fused at the bottom to the staminal tube. So this is representing the staminal tube, this circle, and how you join the petals is like this to the circle. So it shows that the petals are fused at the base. Okay, and also epipetalous condition. Then all the anthers you can draw here, there were many in number and attached to the staminal tube in one bundle, so that also we can represent it in this way. Coming to the center, the centermost was the gynoecium, occupied by gynoecium, and we saw that the gynoecium had 5 carpels, and so it is pentacarpellary, and the placentation is axile placentation. You know this type of placentation where there is a septa dividing the ovule is called as a is axile placentation. So arrangement of ovules is in the form of axile placentation, and it is all joint fused together, so it's a syncarpous ovary. So that is the floral diagram and the floral formula. Thank you.